Sometimes we get such a thing like log a base a. So this kind of a thing always becomes 1. As you know, like, okay, even if you think log a base a equal to, pretend it is a k, and if we do it in exponential form, a goes here, then a equal to a to the power of k. So this is nothing but 1. So when bases are same, powers are same, nothing but k equal to 1. So whenever we see like logarithm of some value and the base, if both are matching, that is nothing but 1. So we in our, if somebody asks what is the proof, then we can do this one. We can let log a base a equal to k, then a equal to a to the power of k. If we write it in the exponential form, then k becomes 1. Provided what? If anything we are writing in this form means we have to write a not equal to 1. So all that time, so the base can't be 1. So remember this point all the time. So whenever we are writing all these things, so we have to think this is in our mind. So this is one principle that you need to remember. So when both are same, the value becomes 1. This is a proof. Hello, and we also learned logarithm of anything base a. So log 1 of any base, so it becomes 0. So we know that. So we can use the same principle that if you don't know this one, first we'll think about like, let this equal to y, then 1 equal to, if a goes on the other side, it becomes like this one, exponential. Then what is, if you want to write 1 in terms of powers, it will become like this. Then bases are same, so when we do the powers, y equal to 0. So we are, so first initially we let logarithm of 1 base a equal to y, so we got y equal to 0. That means what? Logarithm of 1 base a equal to 0. Okay, remember, so when it is 1, the value is 0. When both are same, it is equal to 1. Remember these two, and there are many other things that we will get to know. I'm not sure in your examination you can use this or not, but better to remember. So you see that log a base b equal to 1 by log b base a. This is another property. Let's see the proof of it. So provided, okay, here I could see base a, here I could see base a, sorry, here base b and here base a. So we can write two things. A must not equal to 1 and b also must not equal to 1. So always remember, when there is a base, if you could write some logarithm with some base, put a not equal to 1, or what are the base not equal to 1. Remember this one. So let's prove this one. So this is the same thing. So the proof is so the proof is as is, like, okay, first we'll go with log a base b, we'll take y, then a equal to b to the power of y, right? If we write this one, if b goes on the other side, it will become like this. So we know that b to the power of y equal to a. Yep, let's write raising to the power 1 by y on both sides. So this is nothing but raising to the power. So I'm writing raising to the power 1 by y on both sides. So it's nothing but b to the power of 1 by y here, a to the power of 1 by y. So the principle here is a to the power of n to the power of n equal to a to the power of mn. So I applied the same principle here. B to the power of y to the power of 1 by y. So it becomes b to the power of y into 1 by y. So it is nothing but b equal to a to the power of 1 by y. If you write this one, it becomes, I just swapped it, then 1 by y equal to log b base a, right? So what we got? Log a by b equal to log 1. So what is 1 by y? If we replace y with log a by b, so just copying this one here, 1 by y equal to log b base a, y is log a base b. So it is nothing but when we are writing 1 by, so just base becomes the logarithm and logarithm becomes the base. So log a by b becomes log b by a. So if you remember all these things, then it would help in our problem solving. So somehow this is not mentioned in your properties of logarithm, but remember this might help you. So we can write this one. So not sure how the teachers would react, but whenever we try to avoid it when we are doing the problems, because this property is not defined as per the curriculum. So I'm not sure how teachers would react when they are evaluating your papers. If you use this principle, they say like, this principle is not discussed in our textbook, then how can you apply this principle? Some teachers would have their opinion, so let's not get into this one. If you don't have time sometime, and if you have to go with that one and finish your problem, but if you have time, we try to avoid this one because it is not discussed in your curriculum. Thank you. Yep, there is one other thing that is part of your curriculum, a to the power of log n base a equal to n. So how we will prove this one? So let's take a log n base a equal to y, right? So, and if we apply log, let's assume log n base a equal to k. Okay, then we'll to the power of a to the power of k equal to y, right? Then what is k? K equal to log y base a, right? We can write it like this. So what is k? Log n base. So in examination we can't write all these things. We have to write something very explanative, like replacing k with log n base a from, if we take this as equation 1, then we have to write from equation 1, then so log n base a equal to log y base a, which means y equal to n. So our initial y is nothing but, then again you have to write replacing y with this value from equation, whatever you place it, like let's take these two. Technically this is 1 and this is 2, so you have to say like, then y is nothing but a log n base a equal to n. We proved. So I don't think we will be using this one many times, so we'll stick to our basic properties: product rule, quotient rule, and what is that, power rule. So we only stick to that one and we'll try to finish all the exercises. So this is nothing but, okay, we are simply twisting a little bit here and there and getting the results. It might come as prove this one or something, or solve this one, show that this equal to this, something like that, but try to understand the proof. Thank you.